Hi, welcome to a new edition of the Build Tech Talks. My name is Sjoukje Zaal and I will be your host again for this evening. Tonight, we are going to focus on containerized and distributed apps on Azure. Our speakers will show you how to build containers in Azure and how you can monitor and debug distributed systems in Azure as well. So we have two amazing sessions tonight. We start with Pieter Donkers, and he will show us how you can easily containerize your applications and run them in Azure. He will focus on the different options on how you can host your containers in Azure and the advantages and the disadvantages of these options as well. Next, we have Yusuf, and he will show us how to monitor and debug distributed systems in Azure by using the various tools and services that Azure Monitor has to offer for this. So we're going to focus on a lot of interesting stuff tonight. If you have any questions during these sessions, please ask them in the chat and I will pass them on to each speaker at the end of the session. So let's introduce our first speaker now, Pieter Donkers. Hi, Pieter. How are you?
Yes, I'm fine. Thank you.
So you recently joined Capgemini, right?
Yes. Yeah. Oh, sorry.
No, please.
Yes, yeah, tonight. So I've started in January, so I'm almost in my second month. Yeah, and having a good time until now.
Great. And started a new assignment with Azure, right?
Yes, so I currently am at a client working as a DevOps engineer, mainly in Azure. So yeah, fun.
Great. Also some containerized apps over there, or is this something you do on the side?
Not that much. It's something indeed I've learned in the past, used on the site, and yeah, of course, it's one of the basics these days in platform as a service, of course.
Yeah, it is. So show us what are all the options that you can use on Azure.
Yes, let me share the screen. Thank you. So, can you see my presentation? I think so.
Yes, we can see it.
Yes. Okay. So, welcome everyone. Yes, today I'm going to tell you a little bit about containers in Azure. Let me start by saying what we are going to do and what we aren't going to do. So, this session will not be featuring any lengthy code examples or anything. It will be a simple containerized application that I will show you how you are able to run it in Azure and build it, host it, and stuff. So, who am I? I'm Pieter Donkers. I'm working at Capgemini as a software engineer officially, but currently I'm working as a DevOps engineer for my current client. I have a background in electrical engineering and I have a bachelor's in electrical engineering and a master's in software engineering, and a little bit of a background as a software engineer and a consultant. So in my free time, I like to do certain things like dining and having beers with friends. I love riding my motorcycle, and just now I also started to learn how to tinker with them. So I'm trying to be able to fix them. I like cooking and making stews. Like last time I made. Okay, I forgot the name, but no worries. So I love snowboarding and skiing, which sadly I haven't been able to do up to now this year. And I love traveling as much, but that's also a little bit blocked. So we're going to do a little bit of a preface on containers. Most of this stuff is pretty 101, so it's really a basics about containers. And after that, we're going to do a little bit of a demo. So what are containers and why do we use them? So essentially, a container is sort of a mini virtual machine containing a single application with only its dependencies. So in comparison to virtual machines, with a virtual machine in the package, you have to package the entire operating system and all your configuration of the operating system and such with it. But with a container, you can package your application only with the runtime stack it requires. So for instance, if I have a Python application, I just include the Python run stack, I include the libraries required, and I run it in the single application instead of providing a Linux server with Python installed on it, with the correct network stacks and all the things in it that runs my application. This makes this way more lightweight, and in comparison to the old days where you had to container your applications by essentially packaging them in an operating system each. So you can see that here a little bit. You only have your application with your libraries, and that's pretty much it. So another tight comparison to containers are functions, serverless. In Azure, they're called Azure Functions. In AWS, they're called Lambda. So the difference between containers and functions, I'm going to call them functions because we're talking about Azure, is pretty much a container is a small package application with their dependencies and essentially designed to or more or less able to run full time or continuously. And functions are more supposed to be a short piece of code with a single purpose. So for instance, in the bottom I have here two examples. So a function is more like you trigger it, for instance, with an HTTP request. It uploads a file or something and processes it, and then it stops again, and it's not running continuously. And containers are more suited for instantly automatic scaling applications. So let's say that you have a web server, and at one time in the day your load greatly increases, then you can spin up 5 extra containers and load balance across them pretty easily. So some advantages and disadvantages. For instance, containers are very portable, so they run everywhere. And because they have their dependencies included, you can literally just pack them up and run them on another system, no problem. Well, if you compare this to, for instance, Azure Functions or AWS Lambda, they're more supposed to be running on that single platform. It's easier to migrate. They're really flexible, and you have because it's almost like an operating system. You have a lot of control about them. You can easily look into them. You can look into their file system. It's pretty comparatively easy to manage them. Because you have to package it with their dependencies. Of course, it's you have to do some extra administrative work. So you have to manage the dependencies itself instead of your cloud provider doing it for you. So it's a little bit harder to get started on it because, for instance, if you compare it with functions, you almost only need knowledge about coding, and with containers, you also need a little bit of knowledge about how infrastructure and how these containers run. So what essentially do you need when you're building containers? Well, you do 3 steps. So you develop and you build. Well, you most of the people do this using Docker. So you just build you run your build, you test your application locally. Then you can easily write, for instance, a Docker file, pack up your container, run it in Docker, and also run it locally, but then packaged. If all of that is done, you can easily push it to a registry, or it's a registry or a container repository, and from there you can easily deploy it to the hosting environment so that people are actually able to use them. And that can be for hosting, for instance, as web services, but it can also be to do some computing. So for instance, I don't know, maybe you want to generate a Bitcoin. Well, you can do it in a container, but I do not advise you to. So the container registry, it's essentially for storing your container and sharing it between all the people in your team or globally. Some examples of container registries are Docker Hub, the Azure Container Registry, Harbor, AWS. Essentially, every platform has their own container registry. And so when you have built your containers, you push it to the container registry, and then you can just say to a colleague or a friend, okay, you can find my container there. Your friend or colleague can pull it from there, and it automatically runs. They don't have to do any configuration or anything. They just download the container, and it works. And that also works with the automatic deployment. You just write your scripts that automatically deploys it to the cloud. It pushes it to the infrastructure that runs it, and it's fine. So you can also do other things with container registries. So for instance, you can check for security risks. A lot of companies like to do that because you are pretty free with building your containers, but companies can then check all the dependencies. And if they're not on par, they can just block your container from being deployed. So for hosting the containers, we have different options. Today I'm going to talk about 4 of them in this presentation, but we will show 2 of them in the demo. The reason for that is that we will only demo the 2 simplest ones because the last 2 are a bit more complex. So the most simple way of hosting your containers is Azure Container Instances, or ACI. It's really simple. You just essentially click a button, your container automatically deploys to there, to ACI, and it just runs. We're going to show this in the demo, and it's a few clicks and you're done. The counter side of that, it's not really supposed to be for long-running services because it's a little bit expensive. And also it's a little bit of a hard black box to monitor in comparison with other hosting solutions. And it's fully managed by Azure, so you don't have to manage any infrastructure or anything, and that also makes it the simplest solution. You just host your container. The second one will be the Azure App Services for containers. A lot of developers probably already have worked with this, so it makes it for most of them also simple to deploy their containers to the Azure App Services. It's automatically scaling, so if the load goes up, it scales your containers with it, and it's more geared towards long-running services. So for instance, if you want to run your front end and your backend container there, this is a more suitable solution. Also, a nice thing in this one is that you have a free tier in Azure for your infrastructure, which means that you can basically freely develop Azure App Services in here. And if you want to host something for less than an hour, it's also free to do that. The next one is AKS, or Azure Kubernetes Service. This one is a little bit more complex. Kubernetes is essentially a hosting platform for containers. It's really, you have a lot of control about dialing in your infrastructure, and so you can control your infrastructure over different computers, different parts in the world. You can deploy your containers to certain parts. So for instance, let's say that you want to deploy a container that serves people in Latin America, and you have a server here in Europe, somewhere in China, and somewhere in Latin America, then it's really easy to send your container only to Latin America and do it there. Because it's a little bit harder, it does require some specific Kubernetes knowledge to manage this, to debug this, to deploy containers in it. It's a super powerful tool, but it's a bit more complex. The other one is the Azure Service Fabric. So this is essentially for the orchestration of microservices. I asked around a bit, and there's not a lot of people that actually use this, also because of the complexity. It's more towards big organizations which want to manage their entire microservice platform on one thing. So it has automated lifecycle management, orchestration, monitoring, scaling. Everything is in the single platform, but it's pretty complex to set up and actually manage it. So right now we're going to do a short demo. Let me get for this demo, I created a simple containerized application. The application is essentially the template app for an ASP.NET application. The only thing I did was I added a Docker file to it. I will talk with you shortly through it. So what we do is essentially we build the code. So what we do here, I'll start at the beginning. What we do here is we create an environment that is able to build the code. Right here, we copy the dependencies. Sorry, we copy some dependencies to it and then restore all the public dependencies. Right here, we build the code. So it builds the code and it creates all the binaries. And what we do here is we create here a second container that's only for running the code. The reason we do this is that we don't have all the trash that is required for building the application, which makes our containers a little bit bloated. So we built the application in another container, throw that container away, and only copy the binaries that we are able to run to the target application. At last, and the last point, we expose port 80 and we run the DLL. So let me show you quickly what it does. So yeah. So, and using this Docker file, we can easily now, let me get that out of here. So using this Docker file, we can easily just build So we are now building the application and putting it in the runnable container. And so this should be done. Yeah, and as a short demo, we'll run it locally. So this runs the container and that maps port 80 to port 5000. And that will show up as, where do I have the, let's do this. So, and this is essentially the code that we returned from the simple ASP.NET application. So what are we going to do? What we are going to do now is we start by creating the container registry to push our applications to. Then we are going, for the first demo, we're going to push it to the Azure container instances. And for the second demo, we're going to push it to the Azure app services and also create that. And if we have some time left, we will also deploy it via the pipelines in Azure DevOps. So, why is it not there? Yeah. So starting by creating the container registry. So what we are doing now is we are creating a place in the cloud to push all our containers to, host them, share them with our colleagues, just have a central place to for all our containers. So we are going to call it container demo ACR, which is in use. Pieter to that. So essentially, what we did to just create the Azure Container Registry. This is the only thing that we have to do. We just click the button for Container Registry, and we host it. You have some different options, but we're just sticking with the standard one. Click through, and we create it. So, and now we have a place to push our containers to. And let's start by pushing our container to there. So go to resource. What do we have to do to push our container to the container registry? We're going to do it from the command line here, but you have multiple options to push it to the container registry. You can, for instance, could also do it from an Azure DevOps pipeline, automatically push it to the container registry. What is this? So to be able to push it to the container registry, we first have to log in to the registry. And we are going to do that with this link. So you can just press on access key and get a link there. And we're calling Docker login on that link. It will ask us for some login information. And we are logged in. So now we can tag our container. This essentially sets the name in the container registry. So let me check. I'm going to copy paste the line here. So what we do is we tag the container with which we just created. So the container demo. We tag the container that we just created and put it in the container registry that we just created, and I think this was the name. Sorry, and tag it with the registry link that we just created. So, and now we're ready to push it to there. The reason that we added this to it is now we can just push it to that registry. So we're going to Docker push, and we're going to push it to Azure, and then call it this. So right now it's pushing it to the container registry, and we should be seeing it pop up here when it's finished. Did I make a typing mistake? Yeah. Let me do a quick copy. Demo, I think I made a typing mistake. Into sorry guys. Okay, and okay. So now it's pushing it to the registry. This shouldn't take long. So when it's in the registry, it essentially is known in the entire Azure platform that this container is there. So now after this, we can easily go to the Azure container instances or the app services, and just by clicking through the platform, the container is already known. So we see it here, it popped up in the registry, and version 0.1 is there. Nice. So now we are able to use it in the container instances. So again, it's really simple to just deploy a container, which we are now hosting in the registry, but you could also host it, for instance, on Docker Hub, and deploy it publicly. So let's call this container demo. And we're going to select the Azure Container Registry, and you see that automatically pops up. So this is the Azure Container Registry we just created, the image we just put there, and the correct version. And of course, if you have more versions there, it will they will show up there, and you can select the one that you want. We're going to set it to public here, so that it's easy for us to see it. And because we exposed our container, as you saw in the Docker file earlier on port 80, we're just going to leave this on port 80. So this sets some policies about what you should do when the container is failing, and you can set some environment variables like keys or whatever you want to put in there. We're going to create it, and right now it's deploying itself to Azure, and right after this is done, we will also be able to publicly go to the URL and just use the container. So let's say you have a container, you want to share something with a colleague. It's instead of that you have to do some port forwarding to send something to your container or you have to send it to him. You can also just easily deploy it to Azure and share the public link with your colleague. So right now it's deploying, and this should be really quick. So after this, if we have deployed the container instance, you can really easily just pick up the public URL there, paste it in your browser, and it should open up. Oh, did I do? No. Maybe we should wait for another minute. Let's wait for another minute and...
We lost your screen, Pieter.
Oh.
You clicked the wrong button, I guess.
Okay, let me quickly try to fix that. Okay.
Yes, there it is. Okay.
What did you and what didn't you see? Okay, we're going to wait for this real quick. It can take some, because Azure manages this infrastructure. Well, it can take a little bit longer sometimes. In the meantime, we're going to continue with the app service. So okay, maybe it's on me that it's really... No, you see from the container instances, right now it's loaded in the container, it hosted it, and it put it there. And this is automatically public, and it's now running there on the Azure cloud. Nothing you have to do, nothing you have to manage. It's just the container there. And if you want to run it this way and put it, for instance, on your own URL, this part you can manage, and the rest of this you have to do with your own formatting. So let's create an app service. Well, in the same way as we created the Azure Container Instance, it's pretty easy to click together a... Why is it so slow? It's pretty easy to click together a app service with a single container running in it, if my portal wants to load. Yeah. Okay, so same, we're going to select the right resource group. We're going to give it a cool name, which is fine. And we're going to select that we want to run it on a container. Put it down in Europe. And here you can also see that it's really easy to pick the free one. So you see here, this one, F1, apply this, and you have a free running instance running your containers. So we're going to select a single container. If you have a compose file and you want to put multiple containers there, you can also do that. Again, select it from the container registry, and it automatically selects everything. We're not going to fill the startup command because we already said that it should start the web server. We're not going to add anything for the monitoring, no tags, a review. So the problem with this one is it takes a little bit more time to deploy. The problem here is that you can also see that in the logging, it is really pulling all the dependencies in and building it, and it takes a little bit more time. So this should be done fairly quickly, but the container itself starting up takes a little bit longer. So what it's doing now, it's essentially creating the virtual machine that is hosting all the containers in the app service, and then it has to start up the containers. So go to resource. Yeah. So I think we can most easily see it here. Yeah, so this will probably take a little bit longer. I think we can maybe see some logging here already. No, what was it here? So there are some different places that they already put the logs. So for instance, here you can see with logs, but this will take a little bit longer. So in the meantime, I think, how much time do we have left, Sjoukje? I think 8 minutes. So what I'm also going to show you real quick is how you can easily put it into a pipeline. So let's say that you have this project on your Azure DevOps and you also want to automatically deploy it, in this case, to the app service. Well, that's pretty easy. So we just do the same steps that we just did. We're going to build it, we're going to push it to the registry, and we're going to deploy it. So if we select the Docker container here, it will automatically do the most simple things first. So it will add the steps for the build an image, push an image. So, and here we just select the right subscription, the container registry we just created. Well, we want to build it. We select the Docker file. It has a really easy file navigator to just select your Docker file here. We don't have any build arguments right now, and as the name, I'm going to put a custom name there. And this will just pull the build number from the pipeline. And this is a static name now that we set. And so this step will build the entire container. And the next step, we will push it to the container registry. You see it here, push the container. We're going to fill in, I think. Here we go. So as the name now, just as we tagged it in the previous steps, while we were doing this on the command line, we tagged the container that we built here. So this name, where is it? This name. And we did a tag to this name. And also here, so we're going to tag it with the this one. So. Yeah. So now it's after these two steps, it's built and it's pushed to the container registry. But we, in this case, we also want to deploy it to the app service. So I think it's most easy to find it here. Yes. So same steps, building it, giving it, the name. This is the app service we just created in the platform. So the container demo, that is this app service that we just set. And we are going to add the image name that we want to deploy to there. And that's pretty much it for now. I think we're not going to add a configuration file. And if all is well, we should be able to save and run. And it's building right now and deploying it to this app service. And maybe it's not smart to do it double. So you have to really, the app service, you really have to give some time. I've added a couple of times. I didn't took I think 10 minutes before it even published the Docker container. We can also already test it, but I doubt that we will be able to see something. So here you see the same right now you're seeing the same logs as, for instance, if we are building the container locally, and it's also just it's pulling in all the dependencies which we gave to it. So in this case, it would be the .NET runtime, and it's after it's done with that, it's going to deploy it, and we will be able to find it here. But as you see here, it will probably take some time. So I think it's a good idea to already start with some questions, and then we'll just wait for this one.
Okay. Good idea. Good idea. We don't have any questions in the chat window, but we do have one from our colleague, Roel. So his question is, at the beginning of your presentation, you said no configuration or anything. It was about the container images. And does that mean that each container image has its own configuration built in?
So essentially, the only thing it does is it runs the Docker file. So as in no configuration, you don't need to configure any infrastructure or anything. And the Docker engine itself does the manage resources and stuff like that. So the only configuration you have to do is the Docker file. But for instance, if you want to run it in Kubernetes, you have to configure your pods. Stuff like that, and you don't have to do it in this case, or have to install a Docker engine, anything like that.
Okay.
Does that answer the question, Roel, or not?
I think it does. Yeah.
Cool.
Was a solid answer. Yeah. So no questions. Well, Praveen had a suggestion to us, to all of us, not to enable administrative access to your ACR, and in practice, push and pull to be done via service principal. Yeah, that's okay. That's very true. Yeah.
True, very true. For this demo, I found it a little bit too complex to also add that, but totally agree. In a normal production environment, you should be managing that with a service principal.
Of course. Yeah, I wouldn't have done it for this demo too. So too much of a hassle for just demonstrating this.
Yes.
Okay. Do you think that that your application is ready?
Yeah. So we also already. So what you see here is it already pushed it, and it says here on the bottom, initialize successfully, ready to serve request, and we see it running here. So the same as the ACI. It has some random generated values, so the length is not the same, but it is already running in the app service, and it's publicly available. And you can, what was it? Do we have? So running.
Awesome. Great.
So as a giveaway for this presentation, I hope you guys have seen how simple it is to deploy your containerized applications to Azure, run them in them, and also how to, in the end, we did a little bit on how to implement it in your pipeline. Of course, you can also really easily implement it with the releases, but in this case, the pipeline shows everything on how simple it is to actually deploy your containers.
Great session. Thanks.
Thank you.
Yeah. Good overview of all the possibilities inside of Azure. Really great. Yeah. So you now recommend this for all types of applications?
No. Containers have a very specific target problem, and you should not be using them for everything. But for sure, during development, you can now easily just pick up and develop your applications in Azure. But of course, every problem requires its own solution.
Yeah, very true. Very true. Okay, so thank you very much. There are no questions anymore, so I think we will go and move on to our next speaker, which is Yusuf. Hi.
Hi, everyone.
Hi, how are you? Hi, Yusuf. How are you?
I'm fine, thank you. And you?
I'm good as well. Yes, very good. So you have a bit of a different topic tonight?
Correct.
Yeah.
So he talked about deploying your applications and distributed systems, and now we're mostly telling you about how you can monitor and debug it.
Yes, and are you using that in practice as well?
Yes, currently I'm working on a cloud-native solution, and it's fully deployed on Azure, all the components, and I've learned a lot from the challenges that come with it. So With this session, I hope you can also learn from my mistakes and have take some great tips with it.
Okay, sounds great. Good luck.
Thanks. So let's get started. So good evening, everyone. Welcome to my session about Martin debugging distributed systems. First, let me tell you something about myself. My name is Yusuf. I'm a software engineer at Capgemini for the last almost 3 years. I like to watch movies. I'm a big fan of thrillers. I love traveling. Lately, it's not possible at the moment. Hopefully, that will be an option again. And for more information about me or the project I worked in, you can find it at my website, yusuf.nl. So, yeah, distributed systems. It's a little different compared to a monolithic. So on the diagram on the right, you can see a distributed system consists of several components. And it's a pattern and architecture that's shown its benefits the last couple of years, especially when it's combined with a cloud platform. Because it has some great benefits. For example, when a new team member or team joins, it can start working on one component instead of learning the whole source code at once. If a component goes down, it's easier. When a component goes down, it's easier for it won't impact the whole system. And if one component is under heavy load, you can scale that independently. But also has some downsides compared to monolithic. It's a little more difficult to monitor a transaction and the performance of the application because a transaction goes through several components at once. So we won't know how long it takes in total. And if something goes wrong during the transaction, it's hard to pinpoint where it goes wrong. So to tackle those issues, we have Azure Monitor. And Azure Monitor is a service in the Azure cloud that helps you increase the performance and availability of your applications and services. It does so by collecting, analyzing, and acting on telemetry from your cloud environment. So if you look at the diagram, at the center you will see 2 data storages, metrics and logs. These will be filled with data that comes in from the items on the left. This can be an application, a virtual machine, or other resources deployed in Azure. And on the right you'll see functions that will act on those telemetry. In this tech talk, I will only be handling application map, search, and snapshot debug within application insights and automatic alerts. So let's get started with monitoring. Application map is a feature within application insights, and it will visualize the topology of distributed systems. In one view, you can see all the components that are part of your system, and a component is a independently deployable part of your distributed microservices. This can be, for example, a web API, Azure function. And within each component, you can see how many times it failed, how long it took for a request to complete. So it makes it easy for you to spot performance bottlenecks and failure hotspots. But it may occur that you won't see all the telemetry. For example, if you have a dependency to a resource that's not deployed within Azure, then you can use the application insight SDK to send custom telemetry to Azure, and also then it will get picked up at application map and be shown. I'll be showing this later on in the demo. So you have a lot of telemetry that's being sent from your application to Azure, and with search, you can search and find individual telemetry items. This can be, for example, a trace, a log, a certain request. And when your application gets quite big, a lot of data will be sent to Azure, and it may impact your budget and resource costs. So to fix that, sampling is applied to your data. And sampling is the recommended way to reduce telemetry traffic, data cost, and storage cost while preserving a statistically correct analysis of the application data. There's also an integration within the Visual Studio that you can use, so you can find the telemetry items within Visual Studio instead of going to the portal. I'll also will be showing this later on in the demo. So the first two items, the search and the application map, are used for monitoring actions and behavior that already occurred. And with alerts, you can be proactively notified. And the way alerts work is, on the right you see a diagram, and you have the target resource and the criteria. The combination of that two will define the alert rule. So the target resource is something you want to track its behavior. This can be all the items within your application insights, or a virtual machine, or even an app service. The signal is, for example, the HTTP requests. An alert has to be fired, and when that alert is fired, an action group will be notified, so they can investigate the issue. And the action group can be, for example, a notification group. So you send the email describing the situation, or it can be connected to a webhook or a logic app, for example. And when the criteria is specified an alert rule is met, an alert is created or fired, it has a status of new, and you can change the status when you acknowledge the alert and when you close it. All the state changes are saved in the history of the alert. And it's very useful for you when you want to monitor irregular behavior. So now, we handled monitoring. Now let's look into debugging. Snapshot Debugger is a feature within Application Insights, and it's very useful for when an exception or issue occurs within your live application, and you want to look into it. The way Snapshot Debugger works is it collects snapshots on your top showing exceptions, so that you have information you need to diagnose the issues in production. It's very useful when an exception occurs in your live application. And the snapshot contains the state of the source code and variables the moment the exception was thrown. There's also an integration within Visual Studio, so that you can click on each within the stack trace of the exception and see what the state of the code was. You can view this in the portal and also in Visual Studio. And also, I will show you both later on. And sometimes it's not enough just to use the Snapshot Debugger. Sometimes you need to debug the live application. And this works similarly to local debugging. The only difference is you'll be attaching to a process of your deployed application in production, for example. Before you can do that, you first need to deploy your application using the debug configuration. It's recommended that you don't do this on an environment where the users are using the application at the moment. So a staging slot can be very useful for that. So I've shown a lot of theory, what these subjects mean, and I also made a small demo application to show you how we can use these concepts within our system. So the demo application consists of two services. So you have a web API that uses the application inside, that uses the service bus SDK to put messages on a queue within the service bus. Then you also have a function I made that listens to that queue, and when a new message arrives, it gets triggered and starts performing some business logic. When it's finished, it will save the changes to a table storage. The API also has the option to get the details from within a store. And then these two services also have two dependencies, the service bus and the table storage. Before you can start monitoring debugging, you first need to do some actions first. So you need to create the application insight resource. You need to deploy your both services, the API and the Azure functions. And then on both of the resources, you need to enable application insights. And now I'll be showing you the first part, creating the application insights in the Azure portal. Oh. Go back. So let's go to the Azure resource, Azure portal. So I'll be creating the application insights. So as you can see, I already created an application insights, but I will show you the information you need to fill in this to create this resource. So first you'll select a subscription, assign it to a resource group, give it a name, a region, and then you can choose a resource mode. It is advised that you use workspace-based, because then you get the full integration with log analytics, and the classic one, it will be deprecated soon. So after you create this resource, you need to deploy your API and function. So I'll be showing first the API. So it's a regular ASP.NET Core API, and I'll be deploying this. For the sake of the demo, I'll be using the publish window within Visual Studio. I already set this to configuration to debug, so I'll be using this later on for the snapshot debugger. And I've set the service dependencies. I also made one change to this project, and that is the telemetry initializer. This uses an interface from the Application Insights SDK, and the great thing about this is you can override the default role name and role instance within an application map. So it makes it easier for you to recognize your API when I show you later on the application map. So I'll be using this to deploy. I already deployed this for the sake of time, and you need to do both the same for the function. So it's just a regular Azure function project. As you can see, it has a trigger within the service bus and some business logic. And as you can see, there's a dependency telemetry object, and this is from the Application Insights SDK as well. And what this does is this gives you the option to supplement information, the missing telemetry you have in the application map. So if I show you, I'll show you the publish window, and it's the same as the other one, as the API. So I've set the Application Insights dependency. I already created a publish profile for the sake of time, and then you can publish. And if it's successful, then if you go back to your portal, I already deployed it, but if it's going right, then when you go to App Services, you will see your both resources, an API and a function. And because we already created the Azure, the Application Insights resource, now we need to, and we already deployed this, now we need to enable this Application Insights on both resources. So if you go to Application Insights, and it's just a matter of a switch of a button, and then you have the integration within Application Insights. And if you go further down to .NET Core, there's some additional configuration you can pass into the Application Insights. And I already enabled the snapshot debugger. So that shows how easy it is when you deploy to an app service, and the connection with Application Insights is just deploying it, and the deployment I did within Visual Studio, but it can also be within the pipeline or anything else. So you go to function. It takes a while to load, and then yeah. So as you can see, it's just a matter of a button, enabling it and selecting your previously created Application Insights resource. So that's how easy it is to connect those two together. And now let's fire some requests to our API. Start monitoring and debugging. So what this request now is going to do is it's going to send 3 requests. You're going to send a budget. You're going to create 3 requests to the service bus, and then the worker, the function, will pick it up and process it and save the changes to the table storage. And I'll zoom in a little, so you can see the base URL. I use a placeholder. This will be sent to the our API in Azure. As you can see, it went fine. And now let's get the details of one of our operations. So for example, store to 11, I want to get the details of it. Okay, so you can see something went wrong. And now let's go to application map and start fixing that issue. So I'll go to application insights, and so when you go first to application insights, the overview will show you a brief overview of how your resources are managing. So you can see there were 4 requests that came into our resources that connected to application insights. When I click on application map, yeah. So the cool thing about this is, if you look closely, you will notice it looks kind of similar to the architecture diagram of our distributed system I showed earlier. So if I go back a little, this now kind of matches this. And what you're seeing here is like the 2 green circles are our components. So these are the 2 APIs I've deployed within a service. And if I zoom in a little, it takes a while to load the data. And I'll show you last. Yeah, so it loaded. So I'll start it here. So you have here the API, and it sent a message to the service bus using the application, using the service bus SDK. And if I click on this, you can see you can investigate this transaction, the request that went to the service bus. And here you can see a timeline of the request, and down on the right bottom, you can see sample, and then this will show you all the transactions that belongs to this actions. And there's only one at the moment. So if I click on this, I'll collect this all a little bit more. Here you can see the whole transaction from A to Z. So from the moment it went to the API endpoint. So this is the endpoint we called earlier. And what it does is it uses the SDK to send 3 messages to the service bus, and these are the 3 messages. And you can see it got picked up by the function. And if I go a little more right, you can see the function then called the table storage to get something from it. It also called another dependency called stores.com to get the invoice, and then later on save the changes to the table storage. That's the put operation. So if we go back now to our code in the function, so you can see here I did a table retrieve operation, so that explains the get operation. Then you can see here our custom telemetry we added to the application map. So you can see here the stores.com, and at the end, if everything went right, you can see here the table insert or replace. So this is the put operation. So that's the cool thing about the application map and the transactions that belongs with it. So it makes it easy for you to view if something goes right, and you can also see if something goes wrong, why it goes wrong. For the details operation failed earlier, and you can see exactly like the failed dependency. So I'm seeing that the connection with table store went wrong, and I'm getting no reference. So I already know what it may be, and I will do the same. Go to this endpoint, and I'm seeing here already that when I try to call the storage, storage account, I'm getting a 404, so that will explain the no reference. So if we go back to application map, so as I said earlier, it's easy for you to find the hotspots of failures and places where it may have some issues. So now let's go to search. And as there, here you can find all the individual telemetry items. So if I want to find all the telemetry that belongs to the failing request, let's find the role name. So you can see here you will find the custom API name I've set earlier. So now I'm seeing all the telemetry that belongs to this role, our API. I'm actually only interested in finding the failed ones. It always takes a minute. So successful request, I want false. And you can see here all the, and this one's for the last 24 hours, so I'll say last 4 hours to narrow it down. Yeah, so as you can see, it just makes it easy for you to spot the issues and hotspots of your application. And this way, and you can just keep narrowing it down till you find the individual telemetry you need. There's also an integration within Visual Studio, I've shown earlier. When you go to the Connect Services window within Visual Studio, when you add the integration within application insights, if you do this, then it will get the telemetry from your application insights on Azure. So you get all the data locally in your editor. And if you have Code Lens enabled, then if you enable this show IntelliTrace, then the great thing within Visual Studio and application insights is you can see here. It takes a minute to load. Yeah, for example, where was it? Here, the details endpoint. You can see here all the exceptions that occurred on this endpoint. So you can see here all the last 24 hours the exceptions occurred, and there were 5 in live production. And if you go to see all live, then you can find these all here locally instead of trying to search in the portal. And it really helps with when you're working on a project. If you can find you don't have to go to the application each time. You'll be notified of the mistakes of your past here in the editor. The last thing I want to show you from the monitoring side is alerts. So currently here we see all the alerts that have been fired. I have 2 alerts enabled. Let's look at how alert is defined. And I made a custom alert called high load alert. So if I click on it, you can see here the scope. And the scope is the target resource you want to monitor. So I said all the resources within my application insights are connected to that. And the condition. And if I click on it, now the condition is whenever the count of server request is greater than 100. So this view makes it really easy to make your custom request. So I said here, if the amount of requests is greater than 100, so count over a period of 5 minutes with a frequency of every minute, then an alert needs to be fired. And 100 may seem a lot, but you'll see here what it currently is over the last 6 hours. So if I can see the last 6 hours, the highest was 8. So if I put in notify me when it's for example 4, you can see the line being shown and how often, which ones are the outliers. So 4 may be a little too low, so maybe to be safe, 20 is maybe a more realistic one. So now let's go to the debugging part in Visual Studio. First, I will start with the snapshot debugger. And that, as I said earlier, snapshot debugger will show you the state of the source code and variables the moment an exception has occurred. So I'll go to the endpoint that was failing earlier, so store/details. And you can see here the exception that was thrown. And next to the operation folder, now you have snapshots. So if you click on it, you can see here a snapshot of the source code of your live application. And you can see the stack trace. And so you can click through the stack trace, see what the source code is, what the variables were at the moment. And there's also an option to view the deep compiled code, but this is currently in preview. So if I go to the top row exception, I can see here the number was 11, the argument we gave into the endpoint, the exception, and also some variables. So I can see here already this was the retrieve option, and this is the result of the retrieve option. And if I collapse it, I'm seeing here a 404. And I'm also seeing that the store variable is null. So if I go back to our API, to this endpoint, you can see here there was the retrieve operation, the variable, the result. And so this one is null, and because I'm trying to get a property with something that's null, I will get the null reference. So that explains it. And this is something that's a cool thing about Azure. But you can also view this within Visual Studio Snapshot Debugger and make some extra snapshots in code. So for that, you need to go to the Cloud Explorer. First of all, you need to log in with your MSDN account. And I go to the resource. So when I'm in subscription, go to the resource, app services, and store demo app. And I will say attach snapshot debugger. And then you need to select your storage account. So this is where all the telemetry will be saved when you make a snapshot. I'll say attach. This may take a while. So the way now it works is it's very similar to a snapshot debugger you've shown earlier in the portal, but the benefit of you doing it in the editor is you can decide where you want to have your snapshots. So I'll put this a little down. So I'm only interested in the snapshot here on the left. So the moment it returns this, now it's loading all the symbols of the dependencies we're using in this project. Yeah, so because it needs to it will try to make the snapshot debugger at them locally, and normally you won't notice this if it's on the portal. And I think it's almost done. Because if it's finished loading, then you will see this will be an option to record, and you will have the start collection menu. I'm seeing you failed to get a response. Right, so it's done loading. So now you can see here start collection button. So now I can start recording our snapshot. So I'm only interested in the snapshot just a moment before this exception occurs. So I'll say start collecting. And now it is collecting. So now I need to trigger this event again, and I'll call the failing endpoint again. Send. You can see I get 500 back again. And if still successfully, you can see here the snapshot it made on this line and how long it took. And when it hits your point here, your debug point, your snapshot point, then it will stop collecting data. You can now view your snapshot in the editor. So yeah, I think that's one of the issues I always have with the sample debugger. Sometimes it works. I'm seeing here it's now unable to connect to our remote debugger. So I'm going to try it one more time, and then I'm going to switch over to remote debugging. So yeah, so no option to view the snapshot debugger in Visual Studio. So luckily we can view it in the editor in the portal, but I'll stop this part. So not a big issue. We can switch over to remote debugging, and the way it works is you can say attach to a process, and it takes a while to load. And I'll say here, oh, okay, so let's try again, find. Exciting part, so let's see if this works. It is currently not possible, so but not that big of an issue. So for some reason I can't connect to the endpoint, but let's move on, and maybe I'll try it again later on. So if we go back to our presentation. So yeah, so in summary, is you'll get a lot of features, features out of the box with Application Insights and Azure Monitor. It is just a matter of deploying application to Azure and switch up hit of a button, then it will be connected together and will start collecting telemetry. And even if you're missing some telemetry, you can supplement it with Application Insights SDK. With when you enable Application Insights, you will start collecting a lot of telemetry. You can analyze it with using application map and search, and you can act on those telemetry using remote debugging to find the issues and fix it, or snapshot debugger. And if you want to be notified of future behavior, irregular behavior, then you can use alerts. And in this session, I'm only showing you the application insights and alerts, but there's still so much more I haven't gotten to. So yeah, maybe let's start with the questions, and then I'll try in the meantime to get it working again with Snapshot Debugger.
Yes, great session.
Thanks.
The demo gods were not really in your favor, but maybe they are later on. Yeah.
Exactly.
This always happens during live sessions. Huh? But we have a couple of questions. The first one is from Chasing Dreams. And the question is, would you advise to limit the amount of users that have permissions to Application Insights due to the risk of revealing sensitive information? Or is this not the case?
Yeah, I think it's the Application Insights. It really depends on what you send to Application Insights. So I've shown you earlier, like you can use custom telemetry to send custom data, but it's advisable always to get the least amount of privilege needed. That's what I would do.
Yeah. Okay. We have another question from Party Yaryan. I hope I pronounce it well. How is personally identifiable identifiable information handled when sent through the API and seen here when you are debugging?
So within application insights, you won't see the request message. Like when I show you application map, you only see a request is sent and metadata about the request. But as long if you don't log the message being sent through the line, then you won't see it, the details of the message being saved within application insights.
Okay, yeah, of course. And of course, Roel had some questions as well. So his question is, the app service had some really nice integrations with application insights. Does this work for Linux app services and containerized app services just as easily?
There are some limitations because I've only shown you now how you can do it with application insight with the app service. I know that for Linux it works the same, but I'm not sure for when it comes to containers. I haven't tried that option yet, and maybe something we can handle in the next tech talk.
Okay, good idea. Good idea. Last one, you showed customizing the role name to make it easier to find your application using filters.
Yeah.
Is there a good alternative to this, so you don't have to hard code this in your code base?
Yes, this is now I didn't hard code it, but you can configure this using the app settings. And when you use app settings, you can set those variables using variables within Azure DevOps or another pipeline tool. So I wouldn't recommend it hard coding it is now within code, but something you read within an app settings or a configuration-like tool.
Okay. Okay. Yeah. Yes. Okay. Do you want to look at your demo again?
Yeah. So I'm trying to attach it again. So I'll try remote debugging again.
Okay.
But,
we lost your screen right now.
Oh,
so,
yeah. My bad. But I don't think it's
No. Then we skip it.
not this
No.
tech talk. Sorry, but I owe you guys one demo part later, so stay tuned.
Okay. We will keep that in mind. So thank you very much. Really great session, and Application Insights is an awesome tool for debugging and logging, and a lot of possibilities. And I really like that application map. Really looks cool.
Thanks.
Yeah, good session. Thank you.
You're welcome.
So this concludes this edition of the Build Tech Talks. And this evening and all the future sessions will be shared on our YouTube channel. If you're interested in more of this, please subscribe to this channel or to our Twitch channel. And of course, you can also sign up to our Capgemini digital meetup channel as well. And the meetup URL will be shared in the description below. So our next Build Tech Talk will be on March 9, and it will be about interaction design and UX testing. So join us on Tuesday, March 9. Thank you all for watching, and hopefully till next time.